In this video, we'll take up the homework on word problems involving right triangles. So in the first question, we have a double right triangle problem. So don't forget the right angle marking. To solve the distance between the two buildings, use a tan ratio and solve for how much taller the taller building is compared to the shorter building in order to find the height of the taller building. For question 2, we want to solve for this interior angle using the sine ratio. This is the angle the wire makes at the roof. And then you can solve for the third side of this triangle using Pythagorean theorem. You could use the cosine ratio or the tan ratio, but just in case theta is incorrect, I think the Pythagorean theorem is the safest thing to do. For question 3, once again, you have a double right triangle problem. Very similar to the first question, but you can solve for the height of the falls, solve for x, and then solve for y, and you can have the height of the falls. For question 4, we want to solve for the height of the building. Not much to say here. It was a rather simple diagram, but use a tan ratio and you'll have the height. For question 5, you want to find the distance from the helicopter to the car. So this one, be careful, it's not the horizontal distance. You want the actual distance from the helicopter to the car. It sounds like a Fast and the Furious scene, but yeah, you want to find the distance from the helicopter to the car. So use a sine ratio because it's opposite and hypotenuse is involved. For question 6, it's also sine because you want to solve for the acute angle. You have the opposite side and you have the hypotenuse. So yeah, inverse sine, and it'll give you the angle of inclination. For question 7, we have a double right triangle. To see how much taller the taller tree is, you solve for the height of the taller tree and the height of the shorter tree, and then find the difference. For question 8, this one's a very interesting question. You actually use a tan ratio twice, and then you have to isolate for x, and then you perform a substitution, and then you'll know that the building is 10.4 meters tall. Okay, just watch your calculations here, and be careful when you solve for h. For question 9, you're just solving for the angle by using the inverse tan ratio, or inverse tan function, sorry. For question 10, if they're on the same side of the boat, or same side of the tower, is it? The same side of the lighthouse, sorry, then you find the difference between y and x, and if they're on opposite sides of the lighthouse, then you need to find the sum of x and y. For question 11, this is once again you perform a substitution. Yeah, it's very similar to question 8. So yeah, use the tan ratio 2 times, isolate, and then perform a substitution. I really like question 12. If you think about question 12, the y-intercept of the line is irrelevant because if you're trying to find the acute angle between the line and the x-axis, all you care about is the slope, because the rise and the run will actually give you the sides of the right triangle, or the lengths of the opposite and adjacent side of the right triangle, and then inverse tan, and that will give you the acute angle. Just be careful, make sure they're asking for the acute angle, because if they ask for the obtuse angle, you have to give the obtuse angle. Question 13, I really like it. You solve for the height using the sine ratio and find the area and multiply by the fact 1.5 because it costs $1.50 per square meter of sod, or to cover his yard with sod. Okay, 14 is just like 8 and just like 11. Use a tan ratio 2 times, isolate, perform a substitution. Question 15, this one was not that bad, I think. You can actually solve for the opposite, the side opposite to the 8.5 degrees because it's a difference between the 3 and 1.2. And once you get that done, you can use the tan ratio, and then you can solve for how wide the river is. 12.04. Let's make that a little nicer. 12.04 meters. Okay, and that was a pretty good review or homework sheet on solving word problems involving right triangles. At the end of the day, you just want to draw the diagram if it's not provided for you, and then just take it slow and is it a double right triangle problem? Is it a single right triangle problem? And make sure you pick the right ratio.